The Grenton Academy, Part 4, the Grenton System Power Supply. Hello, my name is Marek Pollitt and I invite you to the next part of our training, where you will learn how to properly power up the Grenton system. From previous videos, you have already learned how to prepare the wiring of the electrical installation for the needs of the smart home system and how to properly make the bus of the Grenton system. Now, as a brief reminder, I would like you to see the slide of a properly made system bus once again. If you remember correctly, the maximum bus length is 300 meters. The bus cannot be looped and you cannot use taps, i.e. we do not use star topology, and you use the Grenton Smart Home cable to make the bus. And now let's get to the issue of power up. What is very important? You use 24 volt DC to supply the system, and when it comes to supplying the system in general, the system can be powered from both the CLU module side and the bus side. And now very important information, it cannot be connected because CLU is not a power supply. CLU is a controller to which you connect an external power supply as well as to the bus and to the CLU. You cannot connect any voltage higher than 24 volts DC. It is absolutely unacceptable to use 230 volt AC here. It will simply damage the control devices. Let's move to the power supply and start from the basic issue, i.e. the method of choosing the power supply. The system, in order to work properly, needs to be powered with the appropriate voltage. And here, not only the size of this voltage matters, i.e. 24 volt DC, but also the power supply that is used to power the system must be well selected to cover the current demand of all modules which will occur in the system. Now, where to get the current demand from? Okay, here you have an example system. You can see CLU, a number of modules, finally a smart panel. Suppose this is a system for a small typical apartment. Before you start assembly work, you should start by designing power for your system. How to do that? First of all, you need to sum up the values of the maximum current demand for all modules that will participate in the system. Where does this value come from? For all modules on our website, you will find technical cards in which we list all technical parameters, and there, in the position we have underlined, i.e. the maximum current consumption, you will find the current demand for the module. We always take the maximum value for power calculations, i.e. we do not take the average, we do not take the minimum. We always take the maximum value. If we look at the example system, you can see the CLU module, the maximum current demand of 100 mA. Relay output modules, 4 HP relay, and also 100 mA each. And here is another remark. You should take into account the maximum current demand for each module. Then you have 67 mA MOSFET dimmer modules, analog in-out, or digital in modules. They have very similar, i.e. approximately 6 mA, and the 80 mA smart LED panel. What is the next step? You add up all these values. The value you received for the system is 632 mA, and then it's very good practice to add some tolerances. For power, it is usually plus 20%. In this case, my calculations show that the current demand with additional tolerance is 750 mA. Now, based on this value, you select the needed power supply from the available series. There is no 800 mA power supply in our offer. We have 630 mA, which is far too small. Maybe in a different way, it will not be too small because when you look at the basic value, it is still within the norms. It is basically already on the border of current demand, while for the safety and stability of the system, you should, however, take into account this tolerance, which means that your power supply will simply be too small. In this case, you take another series, i.e. for systems whose current demand for all modules is 632 mA, you choose a 24 volt 1.5 amp power supply. And you should do this every time you start working on the system. And I think the best moment is when you design the system. If you already have all the modules to implement all the functions in your smart home system, then in the next step you should start work by designing the power supply, choosing the right power supply for your system. System power supply options. Let's move now to the ways in which the system can be powered and which of them is the most optimal, most suitable. First system, power supply from the CLU side. Earlier, I said that the CLU is not a power supply, i.e. it must not be connected to 230 volt AC. That is, we cannot connect it to the socket as it will be damaged. The power supply is connected to the CLU, and the CLU will power the bus through the internal converter, i.e. all devices that are connected to the Grenton TF bus. The bus current capacity is maximum 1 amp. Also, the connectors used are able to bring maximum 1 amp between modules. And now, if the power supply has been chosen before, you know that the modules connected to the CLU have a total current demand of less than 1 amp. i.e., as in the example, 630 mA is a power supply in this case, connected directly to the CLU terminals, and there will be a current capacity greater than 1 amp, which will easily supply such a bus. Once again, to sum up, you connect the power supply directly to the CLU terminals, and then the CLU, through its bus connector, will power all the modules that will be connected to the bus. Remember that maximum 1 amp can be supplied on the CLU bus, and the connectors are also of 1 amp. Another way to power the system is to use redundant power. If you have a larger system than the one on the previous slide, and the current demand ISL is greater than 1 amp, then such a system must be additionally supplied. In the case of the Grenton system, you can do this additional power supply anywhere in the bus, i.e. as shown in the diagram. You have here a 24 volt DC power supply which is connected directly to the CLU, and it is the CLU that supplies the bus through its terminals. Then, as you can see, there is a number of modules for this CLU, and let's assume that the current demand of these modules will be greater than 1 amp. Then, in the place where you have an I/O module connected to the bus just before the touch panel, you use the additional power supply. Here, in the case of this scheme, you have added another power supply next to the CLU, but I will talk about that in a moment. So again, if you plan to mount a larger system, and this system will have a current requirement of 2 to 3 amps, which is also possible, then you have to remember that after each amp, i.e. if you add the current demand for modules, you see that after 10 modules, example 10 4 HP relay modules, the demand will exceed 1 amp. So this is where you should connect the extra power up to the next amp. As you can see in this diagram, you can connect additional power supplies in such places of the bus where this current will be lacking. This issue is very important. Proper system power supply is necessary for the system to work stably, so make sure that the system is powered at all places required. Now let's get back to the power issue, which is located next to the CLU. For this system, this scheme, you use something like power redundancy. See, the CLU module is powered by a 24 volt DC power supply, and right after you used another power supply. In the event that one of these power supplies fails, its function is taken over by the other one, so the system is powered up all the time. The CLU module continues to receive voltage from the power supply, which means that it is able to work constantly. The use of power redundancy increases the stability of the system, so it's worth using on your facilities. So even if the power shows that you need a one power supply to all points on the bus, you should use another one in order to additionally supply the CLU from the supply terminals. This will give us much more stability and confidence that the system will work well longer. Now, in this diagram, you can see exactly how to calculate the power supply. Once again, at the very beginning, you supplied the system with a 24-volt power supply. You have a CLU module whose output has 1 amp. Then you have a number of modules, e.g. 3 are drawn here. But let's assume that the total current demand is greater than 1 amp. So you use another power supply, and again you have more than 1 amp. And again you use another power supply until the end of the bus. You can use additional power supplies in the case of a distributed system, and of course here you also count the current demand, and in the case of a system where there are more than 2 switchboards, then you can use additional power supplies in each switchboard. A very important issue are voltage drops, especially with long buses, i.e. if your system supports a bus longer than 100 to 200 meters, then it's worth measuring the power supply at the ends to make sure that the voltage in each place is correct, i.e. 24 volt DC. How is the power supply realized on the bus? With the use of bus modules. There already is an example of such a properly powered system. The CLU module is connected directly to the 24 volt power supply. Then some modules are connected to the CLU bus, and they are powered directly from the CLU. And in a place where the power is lacking, a bus module and another power supply are applied. There is here another group of modules, another 1 amp, and again another bus module, another power supply. For the bus, you can use one larger power supply. It does not have to be one power supply for each bus module. Such a solution would be certainly the most optimal, because then the bus will be powered from several different power supplies, which increases stability. While in such a system, you can use a more powerful power supply, for example 6 amp, and connect it directly to the bus module. To sum up, you connect a 24 volt DC power supply to the CLU module. On a separate power supply, you then choose the power supply for the joined power supply of all modules that you have on the bus. And from that power supply, you can already use taps, i.e. you lead a cable from one power supply to one bus of the module, then to the next, and thus power the entire bus from one larger power supply with 20% tolerance. Now you can see how I powered up my system. You see that there is one power supply with CLU, and the power supply is connected directly thereto. And furthermore, there is another power supply from which the bus is supplied, and the wire is led to the bus module. The module, which in my case is located at the end of the bus. So if the power supply that powers my CLU module fails, then the CLU will still be powered from the bus side, from the bus module. By the way, you can see how to connect the bus to the bus module. In the case of the bus module, I will show from the connector side that both the power supply and the bus are connected to the cables which are between the bus connectors. In this case, the power supply is connected to the first 2 left connectors, and in the right 2 there is already communication, which in the next step will be connected to the panels located on the object, and exactly in this way you can make connection in your own switchboard. If you wanted to connect the next ones, you start from the CLU side. You have a number of modules. You connect the bus module behind the last one, and from that module you go out via the bus to the object, and you have one branch to the bus. If you would like to make 2 bus branches on your facility, then the same bus module should be mounted on one side of the CLU, connected to the CLU, and then you can connect the other branch of the bus. You can connect power to the bus module from this power supply. As I said before, the correct power supply of the system is crucial for its stable and good operation. So each time after completing the assembly work at the facility, you should make sure that the power supply performed fulfills its function and is made in the correct way. It's worth applying, after completing the work, a few good practices to make sure that the system left at the clients will operate properly. First of all, most power supplies used have the ability to regulate the output voltage. Always power supplies that leave the factory have a set value which is equal to the nominal voltage. So here, before connecting the power supply to the system's devices to the bus module CLU, it's worth attaching it to the power supply and measure its output voltage, then set it to the correct values in the case of a 24 volt DC mean well power supplies. For example, output voltage distribution, it's in the range of 28 to 29 volts to 17 to 18 volts. And these values can be set with a potentiometer. If you connect the power supply to the system, which will be set to 28 to 29 volts, it may end up with damage to the control modules. So please check, before connecting such power supplies, verify that the value given on the output is correct and is equal to 24 volt DC. Another point, before connecting the power supply to the system, or before switching on the power supply voltage for the system to the system power supplies, make sure that the power supply line is not short-circuited. During installation, there are often situations we are not always on site ourselves, so you should be sure that the connection will be secure. Just use a meter to check whether the power line is open or the bus is nowhere shorted, and only then connect and start the system. Another issue worth checking out is first and foremost whether the right power supply has been chosen and if it works properly. For this purpose, turn on the system, all outputs, devices that are in the system, and then measure the voltage at the ends of the bus. First in the switchboard, i.e. start at CLU, then end at the last module, and check whether everywhere the voltage is also 24 volt. Then in the bus, i.e. then connect the bus. Do it in the following way. Connect the modules in the switchboard, disconnect the bus for now, connect the power supply, measure the voltage. If the voltage is correct, connect the bus, then measure the voltage at the ends of this bus. If this voltage is too low anywhere, you must supply that bus additionally and bring it up to the correct value. If your bus operates at a voltage lower than 24 volts, it may not work for some time, but sooner or later, such a system will be unstable. The issue of power is really important, and one last remark at the very end. If you have any service request and the customer reports that the system is unstable, suspended, or acts in an unpredictable way, the first thing you check on arriving at the facility, verify whether the voltage is definitely correct. A fairly frequently reported fault that we encounter in the case of instability is that the power supply is not working, gives low voltage, or is simply damaged. So first, before you attempt a system diagnosis, start by verifying whether it is properly powered. Remember that also other works could have been conducted there, not only those done by you, and that someone else could have caused a short circuit or damaged the power supply, and only when you are sure that the system is properly powered up, you are just starting next tests, next issues that are to be verified. Thank you very much for your attention, and I invite you to the next parts where you will learn how to properly configure and program your system and how to prepare an application for mobile devices.